technology that's called the RAT. So radio access technology will allow the multiple user to access the network at same time, because whatever the wireless generation will be evolved, their main principle that there are multiple mobile who can transmit or receive the information at the same time. It is like if suppose only one mobile is communicating, at that time other mobile cannot communicate, they cannot transmit or receive the information, then definitely no user will use the mobile device. So here multiple users, they are not knowing about each other. Means suppose the time you're talking to your friend, I'm not knowing. Suppose I'm in that same cell, but I'm not knowing you're in the caller node. So your user is not synchronized with the another user. They don't know about another user, what you're doing right now. You're watching the movie, or you're playing some live online game, or you're downloading something. Other user is not knowing about this part. So here users are not synchronized with the other users. So how the multiple user can access the network at the same time, at the same moment, multiple user can transmit or receive their files. So that time the important feature is the RAT that will allow the multiple user to access the network at the same time. That is the reason whatever the different types of RAT you will see in the wireless communication, some of them you already heard, say if you know FDMA, TDMA, CDMA, or their version, next version in the 3G is WCDMA, and 4G will see about the OFDMA. So if you see any RAT, but obviously in every RAT that last 3 alphabet, that is DMA, division multiple access, everywhere. So what does it mean? Division means there will be the division of the resource. Why? So that multiple user can access that resource at the same time. How resource can be shared by the multiple user at the same time? So by dividing that resource among the multiple users, and then multiple user will access the resource at the same time. So in FDMA, TDMA, this thing I think all of you are knowing. Coming in LTE we use the OFDMA technology. Actually, if you see in FDMA, TDMA, what's happened? In those RAT, users are allocated with the single carrier. In say in FDMA, suppose this is your frequency, this is your time. So whole frequency was divided into number of frequency channels. See, in frequency domain, I am dividing the multiple frequency in the small frequency channel. So it can be frequency channel 1, F1, F2, F3, like this way, Fn. If you want to take one example for FDMA, see your GSM use the FDMA plus TDMA technology. So in GSM, your spectrum means uplink frequency. In GSM, in some people who does not have the wireless communications background, please understand, uplink frequency means mobile to network, that is uplink, and network to mobile, that is downlink. So if your mobile have to transmit any information, so mobile will transmit in the uplink frequency. But if mobile have to receive something, that they will receive in the downlink frequency. So say that's the reason in your transmitting the informations, you have two different types of a spectrum, uplink spectrum and the downlink. So in GSM, more popular spectrum was 890 to 915 megahertz. It is the in uplink in GSM more popular spectrum. So that you will see this is the 25 megahertz. In downlink, that the spectrum range is 935 to 960. This is again 25 megahertz. Now this 25 megahertz this bandwidth has to divide it among the multiple users, because this is a resource, means what, that your this bandwidth, this is your resource. So now this resource has to be shared with the multiple user. So in FDMA what will happen, this total bandwidth, say suppose this 25 megahertz of band will be divided into multiple frequency channel. So obviously there will be the bandwidth of each frequency channel. So in GSM the bandwidth of each frequency channel is 200 kilohertz, it is fixed. The bandwidth of each frequency channel, means this channel F1, F2, F3, each frequency channel is 200 kilohertz. So one thing we understand, total band, that is 25 megahertz. Each channel bandwidth is 200 kilohertz. So if we want to know that with this design how many user can access the network at the same time, why? Because in FDMA each frequency channel has given to only one user, means see F1 has given to the mobile one, F2 has given to the user 2. Each frequency channel has given to one user. So if we want to know at a time how many max number of users in a cell can access the network at the same time, means how many max number of users, means indirectly how many max number of your FDMA channel. Well, this is the FDMA channel. We divide the whole frequency into the part of frequency. This is the frequency division. Multiple access means whole frequency is divided into number of frequency channel, and each frequency channel is allocated to one user. Whole frequency will be divided into number of frequency channel, and each frequency channel is allocated to an user, to a single user. So total number, how many number of the frequency channel, or we can say how many max number of user can be allocated. So we have total bandwidth in GSM that we see spectrum, that is 25 megahertz in uplink, 25 megahertz in downlink. So I'm assuming that you're transmitting uplink frequency. So I say suppose this bandwidth is 890 to 915 for example. Same way this is because each user need one uplink frequency channel, one downlink frequency channel, because you can not only transmit, even you have to receive the information. But in this range 890 to 915 is only uplink channel, here you only can transmit. So same way user need one downlink channel. So that downlink channel will range from 935 to 960 megahertz. And again same concept, by applying the same FDMA concept, here you have the number of channels. So user will take one uplink channel, one downlink channel. Now understand here, so how many number of total frequency channel? So total bandwidth is 25 megahertz. Bandwidth of each frequency channel in GSM, you heard that is the 200 kilohertz. So total how many number of frequency channel? Obviously this total divided by each bandwidth. So number of FDMA channel, that is 25 megahertz divided by your 200 kilohertz, and that will come, this 25 megahertz means 25 multiply 10 to power 3 kilohertz, this 200 kilohertz, 2 will go, so it's only 10 will left. Total 125 frequency channel. Okay, so now total we have 125.
Now it's fine. Yeah, now it's fine.
So now we have total 125 frequency means FDMA channels. So it means what we want to say, that we have say one channel given to one user, means at max with this design, with FDMA design, maximum only 125 user can speak at the same time, maximum. Why? Because at the same moment 126 user is trying to call, but there is no free channel, all channels are busy. That's why you listen this situation, if the channel of these routes are busy. That's why RAT is having the very important contribution, why giving the spectrum to the multiple user, how on the same bandwidth, how multiple user can increase the bandwidth efficiency, how can increase the capacity, so that multiple number user can access the network at the same time. For that we don't want any new your generation of technology. In the same generation you change the RAT, and that one example I'm giving you, that is the reason actually in GSM they not use only FDMA, they use the combination of FDMA and TDMA. Why? With the same bandwidth, but when they apply the concept of TDMA, TDMA means one frequency channel will be divided into 8 time slots. Earlier in FDMA, one frequency channel was allocated to single user, but now one frequency channel is divided into 8 time slots. So means indirectly this diagram will be somehow like this. There will be multiple, as I say, multiple frequency channel, and instead of giving one frequency channel, now we'll give the only one slots to the user. Say user 1, user 2, user 3, like this we can give the channel to the multiple users. So now same bandwidth, I'm not going to change the bandwidth, but this is the power of RAT. By changing the RAT means once you combine the FDMA plus TDMA, so the now number of channel become 125 frequency channel, and each channel having the 8 time slots. So see now 1000 users. So that is the main thing, generation to generation. When we move into 2G to 3G, 3G to 4G, your type of service is changing. When 2G was designed, it was completely for the CS service. CS service means the service which does not need the internet. That's called the CS service, means circuit switch. So GSM was completely designed for the CS service. And CS service, user has to be allocated with the dedicated channel, and that example you can see here. This slot, what I'm telling here, say this is say slot 0, this will given to only one user. It is not possible that other user can use the same slot. No. This another slot given to only one user. Because this design is good for the voice service, but as we move, when the 3G generation has come, because I'm telling just basic idea about the 2G, 3G, when 4G will start, I'll tell very details. So as we move into the 3G, third generation of your wireless communication, CS and PS, both service has introduced. Now user has to transmit the circuit switch service, means the voice call, as well as the Packet switch services means that is the internet services, and the main challenging thing in the internet services, there are different types of service. Some services user needs very less data rate, means very less resource. Suppose as you're transmitting only high message on the Skype, so basically this user needs the less resource compared to the other user on the same Skype, but he's now transmitting one audio call. On another user is transmitting some file on the same Skype. All these three different user needs the different amount of resource because their amount of traffic transaction is different. So in the PS service is a very challenging job to handle all this scenario because their amount of traffic varying is very exponential. We cannot predict in next second what going to happen. Means suppose right now your mobile send the request, you want to download the movie. Once you click that website corresponding to the size of that file, your mobile will request the resource to the network. Network allocate the resource and you start to downloading that movie, and maybe in next second before completion of the downloading you can pause. So if you pause means network has to know. Why? Because the resource network has given to you, that resource has to be saved, because now you pause the transmission or reception or downloading, so that resource can be used by the network for the other users. So for that network has to know. So that's happening in the PS service. To handle the PS service was really very challenging jobs. So that's why 3G onward, when you're talking about 3G, 4G, 5G, whatever the different types of technology, all these technologies mainly concentrating about the PS services. And there one example you can understand in 3G, your by default attached domain of your mobile. Default attached domain means if you switch on your mobile in 3G mobile, by default your mobile will register to the CS domain, because suppose your 3G network will support CS and PS both. So by default your mobile registered to the CS domain. But in 4G story is different. 4G packet switch was the primary services. Why? Because 2G when designed, 2G was offering 13.8 kbps data rate. Even with this data rate you get the very good voice quality. If you say channel was not free sir, many time getting the BG call, channel was VG, that is not problem with the data rate, that is problem with the, just now giving the example, number of channel. How many number of, what is the number of frequency operator will buy from the government as the form of spectrum. Based on that spectrum they will plan the number of channel. So how many number of channel is available with that particular operator depends upon that, as many number of subscriber can be adjusted at the same time. But I'm telling about the voice quality. If you have the good signal strength there, then with the 2G protocol, if we are getting the 13.8 kbps data rate, this data rate is enough to provide the very clear voice quality. Then why 3G, 4G, 5G is coming in the market? They are not coming for the voice. Their main concern point was your PS services. Because in PS services, day by day your service types of services is changing, nature of traffic demand is changing, number of user is changing. You see, whatever the number of user right now your LTE is supporting, see 5G is coming with that feature. In future 1000 times whatever the subscriber now 4G is having, if 1000 times subscriber will be increased, traffic consumption will be increased, even though your 5G is capable. Because they observed, you imagine before Reliance they given the free calling data, you imagine a simple example, that time hardly were using 1 GB in a month. But in these 3 years, now you're using 2 GB, 3 GB in a day. 90 times your traffic consumption has increased. So as the load, traffic consumption's load will increase, your LTE will reach to their maximum capacity. So obviously LTE cannot handle those much traffic consumptions. That's reason actually 5G is designed, and that designing that in such a way that if 1000 times your traffic consumption will be increased, that traffic consumption will increase in terms of either your traffic consumption will increase, or number of subscribers will be increased, or there is so many number of devices in future in market it will come which also needs the internet, because data consumption does not you compare with only your mobile communication, mobile consumptions. Now your laptop also using the mobile as a modem, your laptop also using the wireless data only. In future so many IoT device will come that also needs the wireless data, wireless internet. So in that way they're designing, yes, in future if all this device needs the internet consumptions, so 5G must be capable. So in that, when the different technologies coming, their hidden and most powerful thing is the RAT, because RAT is only the principle which will allow the user ki how multiple number of user can be increased to communicate at the same time. And that's I given the example. You see, same 2G, but when you use only FDMA, then one channel, only one user. But when we combine the FDMA plus TDMA, we are not changing the bandwidth, same bandwidth. Operator need not to buy the new bandwidth, same bandwidth, but by changing the RAT, now more number of subscriber can communicate on the same frequency channel. How? By changing the RAT in your, by changing the RAT in the physical layer. So as we move different generation, different types of services, we obviously needs the different types of the RAT. So here FDMA TDMA, what I say their main feature is that each slot will be given to only one user. Please remember, here I'm telling this is very important in LTE. This all concept will be useful. Don't think it's a GSM concept, because FDMA TDMA what you learn in the college time, this is different thing, but we have to learn FDMA TDMA right now in the terms of protocols. So here this very important thing that you understand, in each frequency channel, what I'm telling, this is divided into 8 time slots. So in fact this is called the radio frame. जो नाम सुनते हो रेडियो फ्रेम, that is the same one frequency channel, and that frequency channel is divided into number of time slots. And this concept will not change, because in every technology, if you're going to 2G, 3G, 4G, 5G, and 6G, please mute. Whatever technology if you're going, yes, so whatever wireless communication will go, your information will be transmitted or received in the form of radio frame only. That's when every wireless communication will see the concept radio frame. Radio frame is what just now I said, each frequency channel divided into number of time slots. Only thing is that in different generation, this architecture will be changed, but the concept of radio frame will never change. Always radio frame is having one channel, frequency channel, and that frequency channel, how it will be given in the terms of time slots. That is the design of radio frame. In GSM, one radio frame is having 8 time slots. It's TS0 to TS7. When we move to the 3G, one radio frame will have the 15 time slots. TS0 to TS14. Each radio frame 15 time slots. For 4G, we'll see later on when we'll start the 4G. So if you'll see in different technology, as I said, the concept of radio frame will not change, only their architecture is changing. Why? Because obviously when the 3G has evolved, they have more number of subscribers compared to GSM. their data rate and type of service requirement is different compared to GSM. That's why these slots, all these slots, what I'm telling, that is the called actually resource. Here your user can transmit or receive the information. So as a user, you will get this slot. In GSM, each user is getting one slot. It will never possible that each slot can be allocated to the multiple user in GSM. In GSM, each time slot will be allocated to a single user. Why do I say it's a CS service? CS means a dedicated channel. So each slot given to one user. It's not possible that one slot can be shared with the multiple user. That is reason, if any of you have worked in GSM, you may have seen, in GSM you have never seen the concept of shared channel. GSM में shared channel होता ही नहीं है. Because slots will be given dedicated to a single user, and that's called the dedicated channel. But when we move to the 3G, what happened? We have again more number of subscribers, more different types of services, CS and PS both. In PS service, resource management is very difficult. Why? Just now I say, कि some user have to send the hi message on the Skype, and some message have to transfer the audio file. Some user have to transfer the video file on the Skype, and all these three user obviously have the different amount of the traffic. So they needs the different amount of resource. So here in where we have such kind of situations in CS and PS both or PS services, we cannot guarantee okay each user needs the equal amount of resource. No. That is a very dynamic management. So 3G onward, your bandwidth management was very dynamic. Here in 2G it was a static, everyone one slot. But in 3G it was dynamic management. That's why in 3G one slot can be shared up to 16 user. Each EMTS slot, EMTS means 3G, EMTS slot can be shared up to 16 users. See, concentrate on my sentence. I say up to, means it can be one user, it can be two users, but max one slot can be shared up to 16 users. That I say depends upon your amount of traffic. If suppose you're justifying only one slot, okay, it's given to you. Now other user will not come here. But suppose if you have less amount of traffic, they cannot give you the entire slots. See earlier, in this frame only 8 users can be adjusted, but in 3G in one slot only can adjust as 16 user. If you come into the 4G, situation will be completely different. In 5G again more very different frame architecture. So generation to generation depends upon your requirement. Your frame architecture just like compulsory. If you are reading any new generation in future 6G will come, definitely first of all you must have the in-depth idea about their RAT, which RAT is coming in 5G, how that is different from 4G, because it's RAT only who can actually in the physical layer they will manage the resource. Okay, what is the time, what is the frequency has given to you in a radio frame, how many user can be transmitted or receive their informations. So here see in GSM, if you can see here in one radio frame 8 time slots, but in 3G one radio frame C is a 15 time slots. When we see in the 4G one radio frame will have the 20 time slots. Now next point, if suppose, this is very important point in one time then ask interview in the IRAT handover. I'm not teaching right now handover, but there is slot concept is required to understand that point. In the handover we'll see in details. What is the point here? Actually they ask is suppose if user, as you can understand here, one slot given to only one user. Suppose you have heavier amount of traffic, you have more amount of traffic, one slot is not enough to transmit your this much information. You need suppose more than one slot. So is it possible that any user can be allocated with more than one slot in that same frame? See, one frame you have 8 time slots. So is it possible that any user can be allocated with more than one slots? And again, this is, don't think it's a theory. All this concept will be used in future when you work with the practical on the tools. आपको ये सब concept नहीं अच्छे से आएगा तो then you cannot analyze their logs and their value. So what is my question? Again, I'm repeating. Is it possible that if any user needs more than one slot to transmit their heavier amount of traffic, so is it possible? You will say no, absolutely no. There is no exception. आपको इंटरव्यू बोला कोई exception, no exception. Anyhow, each user will be allocated with only one slot in the same radio frame. That's again next important point you please remember. Only one slot can be allocated to a user in same radio frame. Then what will happen to my question? As I said, if suppose user have heavier amount of traffic and one slot is not enough, if user is having large volume of traffic and suppose one time slot is not enough, then फिर क्या करेंगे? Then you can say yes, more than one slot will be allocated to the user but not in the same frame. That condition will never wrong. Next frame it will possible. So then user can be allocated with another slot, another time slot in next frame. So same frame में नहीं मिलेगा, only possible that you can get in the next frame. And suppose this frame transmission is the continuous process. In GSM, your not GSM actually, if you go 2G, 3G, 4G, in every technology, there will be one terminology, frame duration. Frame duration means how much time one frame will take to transmit from mobile to network or network to mobile. That is standard time. So in GSM that is the 4 point something, but I'm using the 4 millisecond value to make the easier calculation with the slots. So you have TS0, TS1 till say TS7. This is say one radio frame. And understand this radio frame transmission, it will go in 3G, your frame duration is the 10 millisecond. 4G, again frame duration 10 millisecond. So in every technology you have to understand radio frame architecture and their duration. Duration will define how much time this frame will take to transmit from mobile to network. Now one thing understand what I'm telling, anyhow suppose for example this is Prashant, it's allocated to one slot but he has to transmit the more amount of information. Suppose one slot is not enough to transmit his data. And again I'm repeating, this frame transmission is the continuous process. You never think, whenever you have to transmit the user traffic only, then only frame transmit. No, once you switch on the mobile. Once you switch on the mobile, your frame transmission start. You never think that frame will contain only user traffic. Frame will contain signaling also. But if this time is 4 millisecond, means guaranteed in every 4 millisecond, one frame will keep transmitting. Guaranteed. There is no any other exception. Frame transmission is the continuous process. There are many people who think, if I have to transmit the data, then only frame will transmit. No, frame can contain the signaling as well, anything. But in every 4 millisecond in GSM, frame will transmit. Suppose in UMTS, if frame duration is 10 milliseconds, means in every 10 millisecond compulsory, if your mobile is on, compulsory, your frame will transmit in every 10 millisecond in 3G. Whether your mobile in idle mode, whether your mobile in connected mode, you are surfing, chatting or not surfing, you are sleeping in mobile in idle mode, even though this frame will keep transmitting. Because in this frame only, mobile and network will exchange the signaling information. Suppose your mobile have to tell where is my current location. That is not user traffic, that is signaling. But how mobile will inform? Within this frame only, resource will be allocated to your mobile, and mobile will transmit that information within this frame. So now what I'm telling, this is the continuous process. Means if your mobile have to transmit the signaling information, even though those signaling will be transmitted in the frame only. So now coming back to my question, what I said, say suppose. So now suppose, as I said, if suppose this user 1 needs more than one slot, but I said within the same frame, more than one slot can never be allocated to any user. Never. So then how I will transmit? Suppose I just said my amount of data, one time slot is not enough to carry this large amount of traffic. We need more than one slot. So yes, you can be allocated with the another slot, but in the next radio frame. What is it? Can be allocated in the next radio frame, means after say 4 millisecond, once the next frame is transmitting. Because just I say this is a continuous process. So in next frame, yes, this slot will be allocated, say for the same mobile if you have to transmit. And as a user you will not experience this delay. Why? 4 millisecond as a user you can understand, you cannot feel this delay. But definitely when you capture the data, this much delay you have to observe if user have to transmit the information in more than one slot. But within the same frame you cannot get the more than one slot. Now another important point, because I'm telling this is a very important question in Qualcomm. They're asking so many questions about the slots. Because if you're not good with the slots concept, your physical layer concept cannot be that much clear. Next question. So in this another radio frame, say suppose this is your radio frame number 1. That radio frame we represent with the terminology SFN, system frame number. So this system frame SFN, say system frame number 0, and this is your system frame number 1. Again there is 8 time slots. Now next question what they ask. Okay, in next frame another slot will be allocated. So it can be any slot in the next frame or the same slot. Here suppose UE1 is transmitting in this radio frame as TS0. Suppose here TS2, say for example, say this UE1 has allocated to Prashant. Suppose this TS1 has given to say Yusuf. Say TS3 has given to. So now what I'm telling is so Prashant if needs more than one slot, so in the next frame exactly same slot position. So suppose this again Prashant will get the next slot in the same slot TS0. Obviously Yusuf one slot is enough, he transmitted his entire data. So now this TS1 has to give any new user. Let's say ki number of user will keep coming and number of frame also keep transmitting. So now suppose this given to any new user, say Avtar. Now TS3 this Asutosh need more than one slot, so Asutosh will get exactly same slot number. Why it's happening? Understand, this is very important concept here. To make your symmetric transmission. For example, one frame, what I said, 8 time slots, duration 4 millisecond. So this gap we wanted to make it constant. So if suppose here person transmitting in TS0, in next frame he need again another slot. So if the same slot transmitting, then again gap will same like 8 time slots only, na? From here to here again the 8 slots gap, again same 4 millisecond gap. Suppose here also TS3. So here again TS3. Always this 8 time slots gap should be maintained. Otherwise randomly if you allocate anywhere, then writing the program will be very difficult. Why? You understand here. Suppose TS0 you are transmitting here Prashant, here will get the TS7. Prashant will get the TS7 to transmit the next slot. Then gap will be 15 time slots. Almost 8 millisecond. And suppose person needs one more slot and next frame will give in the TS0 only. So here TS7, here TS0. Now gap is only one slot. 4 by 8 millisecond means 0.5 millisecond. Sometime coming 8 millisecond gap, sometime 0.5 millisecond back gap. So better make it symmetric. So it will always 8 time slots gap and always 4 millisecond difference. So that will allocate the symmetric resource allocation. So this point always remember, if user needs more than one slot, so here always, so if user needs more than one slot, it can be allocated, but there is two conditions. Always remember, not within the same frame, in the next frame and same slot position. Next, again important point. Just I'm telling FDMA today, but this I'm telling the different very important concept that's really used for the handover, because in handover you'll see the call flow, that in protocol call flow is not important, the implementation is important. So we have to understand first in the terms of your layers and the slots. You imagine right now, suppose you are in the 2G, for example. You imagine 2G, you're transmitting your information in the 8 time slots. When you move to 3G, suddenly your information is transmitting within the 15 time slots. Handover, we are just concentrating the handover about the call flow, but we never concentrate about the physical layer. You imagine when you are in 2G, your entire information is going in the 8 time slots, but when you move to 3G, you are going in the 15 time slots. In 2G, using the FDMA TDMA. In 3G, we have to use WCDMA. So now, first understand one thing. Suppose you are here, say you have the 2G network, say suppose this is again 3G network. This question I'm asking you, this question has been recently asked in interview. They asked the one question because they're actually asking about the LTE handover, but in LTE they include everything, 3G, 2G, everything they include. So what they asked the question, which handover implementation is easier, 2G to 3G or 3G to 2G? Please let me complete my question, till now I didn't complete. Here if you're thinking, sir, 2G having less data rate, 3G having more data rate, somewhere 2G is available everywhere, maybe 3G is not available. Please don't think like that, because I'm telling you clearly, handover implementation is 2G, 3G both are available. You don't worry about those situations. Now you have to develop the Apple chipset. So in that you have to implement the handover program. So in the handover, there will be SYN-link will be exchanged from mobile to network. So I'm asking that point, 2G to 3G handover will be easier to implement that situation, or 3G to 2G. So while thinking about this answer, never think about 3G network available hai ki nahi hai. That is available, then only I'm implementing the handover, na? So if I'm asking this handover, means this network is available. You don't worry about those points. So actually here 2G to 3G or 3G to 2G, which handover will be easier? See, before just when we are going to implement the handover, okay, understood, because right now you're not in handover. Right now, suppose your 2G call is going on, correct? Na? Yes. So Just before implementing the handover, first of all, it's a mobile only who will initiate the project, because it's a mobile having the receiver. Who will
Yes,
only
yes.
know my neighbor cell is 3G or 4G? Correct?
Mobile will be knowing that actually.
Correct. So how mobile will know?
Yeah.
They have to perform the some kind of measurement. That is layer 3 procedure that we'll see in the layer 3. But actually mobile is performing the layer 3 measurement procedure.
Yeah, measurement processor will be there.
Because with the measurement only your device will know that my neighbor cell is 3G frequency, is 4G frequency. Then your mobile will report to your current network that my neighbor cell is 3G or 4G whatever.
Yes.
But to perform this measurement, because this measurement is a procedure. To perform
Yeah.
this measurement, you need some time. No?
Yeah, yeah. And it's a completely IRAD situation here. It's not.
Yeah, handover means IRAT. This 2G to
Yeah.
3G, 3G to 2G. IRAT, just as you said,
IRAT.
in 2G
Yes,
it's a FDMA, 2G you have RAT is FDMA, 3G
Yes.
RAT is WCDMA. So RAT is
WCDMA.
changing, na? So
Changing,
obviously
yes.
that is IRAT only.
Yes.
So I'm not coming to that point, Prashad. I'm telling about कि understand in the terms of implementation. थोड़ा आप आरब से बाहर हो, थोड़ा आप ऐसे सोचो कि your mobile before performing the handover, first of all, your mobile has to perform the measurement.
Yes.
Correct.
Yes.
To perform this measurement procedure,
Yeah.
measurement is a layer 3 procedure. Mobile have to exchange the signaling with the network. Correct.
Yes.
So to perform this
Yes.
measurement, mobile needs some time. Correct.
Yeah. Yeah. It needs
So-
time
So
exactly.
it needs some time. So now I'm coming to my points. In 2G, already we have idle time slots. That's called the concept.
Frequency reuse concept.
What? No. 20 seconds. 1 second. 1 second. Okay. In 2G, out of 8 time slots, we will have, please mute. We have
Yeah.
one idle time slots. Not ideal, it's the idle time slots. In every frame, out of 8 time slots, 1 slot is idle time slots in 2G. So during this idle time slots, your mobile will use this idle time slots. Within this idle time slot, no data is transmitting, receiving. So during this time, mobile automatically performing the measurement. Automatically. So if suppose right now you're in 2G, so in every frame you getting 1 slot where you can perform the measurement. But in 3G and 4G, I'm not talking about the 4G, but in 3G and 4G, same concept. All slots will be used for signaling and traffic transmission. There is no provision of idle time slots in 3G and 4G.
Yeah, that's right. Actually, that's a correct point. Actually,
That's the
all these
reason.
slots are used in 3G.
That's the reason आप लोग अभी कभी सुने होंगे एक word measurement gap. You may have heard someone in 4G. If you didn't work in the 4G, so you may have heard measurement gap. I'm telling what is that there. So in 3G or 4G, all slots are reserved for your signaling and traffic transmission. There is no idle time slots. Why? Because 3G and 4G used for the higher data rate. So if you have to move from 2G to 3G, then its implementation is easier in protocol developer or tester, because you have one idle time slot. In this slots you will implement the measurement procedures. But now suppose if you're in 3G and you have to move to 2G, but before moving the 2G, first perform the measurement na? Because without measurement handover नहीं हो सकता है. Compulsory measurement you have to perform. Without knowing anyone, you cannot make the friendship, Prashad. Correct na? Otherwise again
That's
the
right.
same
That's
story
right.
will come. Sushant Singh and Riya Chakravarti. So पहले जानना जरूरी है. Please complete the measurement procedure. So here, if your mobile in 3G, your mobile have to complete the measurement procedure, but to complete the measurement procedure, there is no idle time slots. So in 3G and 4G, forcibly this idle time slots has created, developer has to do the additional task to create these time slots. How? Means again one signaling will transmit network first tell to the mobile. Suppose out of this 15 slots, okay, slot number 12th. I'm not transmitting any information in this slot, please perform the measurement. Then mobile will perform the measurement. So here additional steps is required. That's why in 3G this concept is called the compressed mode, and in 4G same concept is known as the measurement gap. Means to perform the measurement, some gap is created in your slots transmission where your mobile will perform the measurement and then perform the handover. So right, I'm not teaching about handover, just I'm telling about the slots. So 2G to 3G handover is easier to implement compared to 3G to 2G, because if you have to implement 3G to 2G or 4G to 2G, you have two options. Either you have to include the two receiver, so one transmitter receiver will be VG for the complete traffic transmission reception, another receiver will be VG for perform the measurement, but it will increase the extra additional cost and increase the size of a device. Then in specifications, one feature has included that is called the compressed mode. In 3G or in 4G is called the measurement gap. According to that, in 3G and 4G, as we know, there is no idle time slots, so forcibly some slots will be created when the measurement is required, and network will inform to the mobile that this slot I am not transmitting any information, so please you perform the measurement, and then mobile will perform the measurement and then initiate the handover. So in 3G to 2G we need this additional step to implement the compressed mode or measurement gap before initiating the measurement procedure. So 3G to 2G handover is the difficult compared to 2G to 3G. Clear, Prashad?
Yeah, I got it. Thanks.
Okay. So अभी तो मैं basic ले आऊँ, today also, tomorrow also basic class, then we'll come to the LTE. But 1-2 classes we have to understand very small concept about the physical layers, slots, RAT, STU,
Yeah,
PDU. Then we'll come to the layers.
This is like actually slot handover and all, right? You are saying about.
No, actually not slot handover. Not sorry. In any handover, compulsory. Whether you are IRAT handover, Prashad. Whether you are IRAT handover, whether it's you have the intra-frequency, inter-frequency, any kind of handover, without slot concept, we cannot study any handover, because whatever the handover reading, you're reading the call flow, no? But this call flow, this message, at last will transmit from the physical layer only.
Physical layer, yes.
This physical layer means this will transmit those information in the slots only. So slot is the concept that will come everywhere.
Okay.
Whatever the call flow you have seen, because earlier you have seen only call flow, so you are seeing only layer 3 message. But here in the protocol, that layer 3 message we have to send in the layer 1. So all the higher layer message will come in the form of slots only. At last it is just clear.
Yes. It will come to physical layer.
Yeah, so अभी पढ़ेंगे, just at last हम लोग देखेंगे कि that message, it all the handover message, all the your layer 3 message will transmit the slot in the form of 0101. So those will also see, because your mobile is not knowing handover request message, paging message, because this is the alphabetical message. Your mobile is digital equipment. They know only 0101. So it is a physical layer job. When it will come from higher layer, each message in the slot will go in the form of 010101 like that. So वो सारा चीज हम पढ़ेंगे धीरे, slowly everything will come. Okay. So we'll see tomorrow. Okay.